Hello everyone, welcome back to the OpHaxor YouTube channel. It is OpHaxor Sam here, and we have a new LeetCode problem. It is 1451, rearrange words in a sentence. And today we're going to talk about why a tree map in Java could be useful. So let's go ahead and go over the problem statement. Given a sentence text, a sentence is a string of space-separated words in the following format. First letter is in uppercase. Each word in text is separated by a single space. Looks like they have a typo there. So each word in the sentence is obviously separated by a space. Your task is to rearrange the words in text such that all words are rearranged in an increasing order of their lengths. If two words have the same length, arrange them in their original order. Return the new text following the format shown above. Okay, so that's pretty simple. Let's go over example 1. The text is LeetCode is cool, so this would be arranged as is cool LeetCode. I think that's pretty self-explanatory. So there are 3 words in the sentence, and they're literally just rearranged from smallest length to largest length. And if you notice, LeetCode has an uppercase L in the first sentence. In the second sentence, it's lowercase, and then the I in is becomes uppercase since it's the first letter in the sentence now. Pretty simple. Example 2, keep common code on. So we have 3 words that are the same length, so you have to keep the original order for those words. That's important. And then example 3, to be or not to be, there's many words with only 2 letters, and obviously they retain the same order. Alright guys, before we go into the IDE to go over the solution, quick whiteboarding session. So our solution here is going to be based off of the Java tree map. So why is a tree map important here? Again, so this is a sorting interview technical question, a coding question. Since we want to maintain ordering of the words in the sentence, a tree map is going to be very, very useful here. And it essentially does the work for us efficiently of sorting the words from smallest to largest. So the basic data structure of our solution is going to be a tree map of an integer to a list of strings. Integer, the reason we have to use an integer is because our keys have to be comparable. Because it's a tree map, we have to maintain order of the keys. And the value is a list of strings because, again, multiple words could have the same length. So the integer here will represent the length of words, words in that list. And this actually represents words of a specified length. And of course, the Java list will maintain insertion order of our words. Also, some interesting facts that you may not know about a tree map is that it is based on the navigable map interface. It is a red-black tree. And it does guarantee log n time for the, apologize for the bad handwriting, for the contains key, get, put, and remove methods. Alright, now let's jump straight into our Eclipse IDE with our solution. So we're going to do a quick debug session here. So I'm going to put my breakpoint, line 15, and this one. Alright, so again, text is keep column and code on. That was actually one of the examples provided by LeetCode. Alright, so yeah, here we're instantiating our tree map. Text.split. So this returns a array, and the words are obviously separated, and the delimiter is the space. So we can see that. Array, yep, keep column and code on. This is just a little check we have. If the length is 0, then we want to just return what we already have. We don't want to run all this stuff. So the first letter of the first word we're going to convert to lowercase, because in our new string it may not be lowercase anymore. So we do that. We can see it worked. Alright, now for each string in the array, first we're going to compute its length. So the length is going to be the key in our tree map. And then what compute if absent does is if that key does not exist in the tree map, then instantiate a new array list. Because the thing is, if we try to just add a string to the location at length, then we would get a null pointer exception because the array list simply has not been instantiated yet. So we instantiate the array list first, if it's absent, and then we simply add s to that array list. So let's see that in action. Okay, we ran it, and then if we open our map, you can see the key here is 4 because keep was 4 letters, and then we have our array list index 0 is keep. Alright, next string is calm, so same thing, 4. So new array list is not going to be run anymore, and we simply add column to that array list that was just created. And we can see that, yep. So we can see keep and column, it's in that same array list at key 4. Next string is and, so we're going to create, that's going to be length 3, so that's a brand new location in the tree map. And we can see it was created here. It was created here because, again, we're maintaining order of keys. So this one comes first. It's very important. And then we can see the array list has value and. So we're just going to breeze through the rest. We know what happens. And we can see that order was maintained. So we have 2, 3, and 4. And alright, so then we create a string builder, and then we literally just iterate through the key set of the map. We get the list, and for each item in the list, we simply append it to our string builder with a space. We're going to continue. Again, the first letter of the first word, we're going to convert to uppercase since it's now the first letter of the sentence. We're going to delete the last character because an extra space was added in the last iteration. And then we simply return. And we're going to print it out, and it's on and keep column code. And it's as simple as that. So yeah, this kind of explains when you should use a tree map with a very practical example. if you need to maintain the order of your keys, and you want to have a value associated with a specified key, then a tree map is a great way to go. Alright, we hope you enjoyed this video. Have a great day. Like and subscribe, and visit our website at OpHaxor.com.